Hey everybody, welcome to the Chapter 3, Section 4 notes over the quadratic functions from tables and graphs. Here I'm going to go over the calculator steps on how to create a quadratic function in standard form. When given a set of points, like you could derive a set of points from a graph, or maybe you have a bunch of points from a table. So I'm just going to do a couple examples here. I have all my steps written down at the top right here. um, so if you're one of my students, it's on your paper. If you're not one of my students, hey, thanks for watching. But maybe you want to write these down. I don't know. But I'm going to go over everything as slowly and as thoroughly as possible. So the first thing I'm going to go over is I'm going to write an equation of the parabola that passes through these points -1, 4, 0, 1, and 2, 7. So I'm going to go to my calculator and I'm going to add a list and spreadsheet, and always, always, always title your columns. So I just simply title them X and Y, but you can type in anything you want. Um, but I have -1, 4. So -1 is my X, 4 is my Y, 0, 1, and 2, 7. 0, 1, 2, and 7. So once you have everything typed in, make sure you've pressed enter on the last item, because a lot of times people mess up if they get error messages because they haven't pressed enter on this last bit of data here. So make sure everything's fully entered. Again, make sure your columns are titled, and then hit Control Doc 1. That's going to add a calculator screen. Then we're going to go to Menu, 6 Statistics, 1 Stat Calculations, and then 6 Quadratic Regression. In the X list, you can click the side to choose X or Y, or you can just simply type in the letters. So whatever you want, but all you need to do is X list say X, Y list says Y, press enter or click OK. And here it's giving you your A, B, and C. So it's giving you the equation in standard form. So A is 2, 2x squared plus bx, b is -1, so -1x, plus c is 1. So here on my paper, I have it written down. Um, a is 2, b is -1, c is 1. So my function will be 2x squared minus x, or maybe you want to write minus 1x, but you traditionally don't write a 1 in front of the letter. So minus x plus 1. And then I ask this question, what is the r squared value? So the r squared value is, in simple terms, a measure of the strength of a correlation between your regression model and your data. So it needs to be as close to the number one as possible for the strongest correlation. So things that are like 0.99 is a very strong correlation. Something that's like zero point 0.8 or zero point 0.7, something like that, that's going to be a weaker correlation. And if you have a 1, that's a perfect correlation. So I wrote yes, it's a perfect correlation, because let's go back to our calculator here. It says r squared equals 1. Um, and so this is kind of extra. You don't really need to know this, but if you want to see just how well your data is correlated, you can do Control Doc and add a data and statistic page. And then the nice thing about this is you click down here, make it your X column, click down over here, make it your Y column. And I have my bits of data, and then I can go to Menu, Actions, and then, Analyze, Regression, and I can go to Show Quadratic, and it runs perfectly through all these points. So that's kind of neat. That's just kind of an extra thing. Um, but yeah, that's all I wanted to say on this first example. Now, I'm going to move on to the next example. And this is something you could conceivably do, right? This is a table of fuel efficiencies at various speeds. So most new cars have a miles per gallon meter, and along with a speedometer, of course. And you could conceivably record various speeds and record down your various miles per gallon at those speeds, and then run a quadratic regression with these. So what I recommend doing is, anytime you need to do another table, just start over, go to a new document, and add a list and spreadsheet, title your columns X and Y. You don't need to type in anything in the equal sign. As an Algebra 2 teacher, I never use those, but it does have a value. It does have merit to be there, just we don't need to use it. So make sure you leave that blank. So I'm going to type all these in 20, 24, 30, 36, all those in the X, all these in the Y. So 20, 24, 30, 36, 40, 45, 50. Oops, I messed up. 40, 45, 50, and then we went 56, 60, 56, 60, and then go over to your Y column, 14.5, 17.5. The nice thing is if you do mess up, you can just like, oh, I typed too many numbers. You just go over and type over it, and then it'll replace it. So we got 23.7, and then I got 25.2, and two 25.8s, and then 25.1, 24. So everything's entered. My titles are, or my columns are titled. So I'm going to go Control Doc 1, and then I'll go Menu 6, 1, 6. X list says X, Y list says Y. Click OK, and then here's my function. So you see I have an R squared of 0.99942442. That's a very strong correlation. It's almost perfect, but perfect would be exactly 1. So I like to round numbers to the nearest 3 decimal places. So you would look at the fourth number to see if it rounds up that third one. So 0.0144, that 4 doesn't round it up. 3890, the 0 doesn't round the 9 up. 524, 3, that 3 does not round up the 4. None of these round up. And then 0.999, that 4 does not round up that 9. So you can just write down all your values right here. Yes, it's a strong correlation. So, I'm showing you this answer that I wanted to go over. What's your optimal driving speed? That would be find the vertex, okay? So how do I find the vertex when I'm given the function? So I just want to show you this because I brought it up earlier. When you do a data and statistics page of this and you go to menu, analyze, regression, show quadratic, it won't explicitly, it'll tell you your function and it shows you, and look how nicely it goes through all those points. But it can't tell you the vertex. In order to get the vertex, you have to go to control doc and add a graph page. And the cool thing about this is once you run a regression, you just have to press the up button and it's typed in. You just need to press enter. When you press enter, then it graphs it. And then from a graph screen, you can get way more information than from this screen. This screen is really good for like a quick kind of way to get your function and then see how well it's correlated because you see the points individually graphed. Whereas here, I just see the function graph. I don't see any of the points here. So I need to zoom out here. So I'm going to go to zoom out, and then you just click until you can see the arch, and then hit escape to stop zooming out. So I see this, and now I need to find the vertex. So I'm going to go to menu, analyze, maximum, click somewhere, highlight, click again. And so I'm going to round these to the nearest whole numbers. So this is about 48, and that's 26. So 48 miles per hour, because that was my X column, 48 miles per hour, gets me 26 miles per gallon. That was my Y column. So using the vertex helped me figure out my optimal driving speed for this vehicle. So if I want to get the best fuel efficiency, I know to drive this car or whatever it is at 48 miles per hour. So yeah, there's everything you need to know about running quadratic regressions in the calculator. Thanks for watching. Bye.